Hello, good afternoon, everyone. Good evening, in fact. Very few people today. What happened? Is there any exam that's going on? Okay, Joshi, Rutvik. Yeah, because I hardly have any number of participants today. Yeah, please, if you can just text in the group that we are starting in another 5 minutes. Let the people come and join in then quickly. Okay. So let's wait. Let's wait for more people to join in. In the meantime, I'll share the PPT. Okay, people are joining in. Okay, let's wait for a couple of minutes. I'm sharing on the PPT. Right. So once we have a good number, start. Oh, yeah, sure. I can. What you can do is you can share in your email IDs, and I can then share a couple of additional resources that you guys can use for fonts as well as verbal. Not like this. Okay. What you can do is, in fact, Josh, all of you. Uh, what I'll do is, in fact, I'll just upload it on one of the, you know, on the Google Drive, and then I can share out the link of the drive with all of you, and then you guys can download it out from there. Because there are so many students, just mailing to each one of one, and again, mailing. Most of the time the size exceeds 25 MB, so that's again a limitation of mailing it out. On a drive, it's much more easier. है ना? So what I'll do is I'll just create an ID, okay, for the VJTI thing, and I'll upload it on the Google Drive, and then on you can access it out. So I'll share out both the quants as well as the verbal things with you that you can use parallelly. Okay, guys, let's wait for 2 more minutes. We have only total of 17 as of now, and let's see if there are some more joining in, and we'll begin in another 2 minutes. All right, guys, let's start. Okay, so in today's session, which is the first class on algebra, we would go through the first phase of the set of questions, which is based on equations. Okay, so the whole, the session, uh, the the discussion today for the equations, we'll have the discussion on the linear equations and then on the quadratic equation. Now, as we see, the concept of linear equations basically broadly divided into two categories. One are simple equations, questions which are based on simple equations, and the questions which are based on simultaneous. Now, when you say a simultaneous, it's always a two variable, two equation set of a system. Okay, they never ask you more than three variables or three equation types or n variable n equation. A simple equation is a one variable, one equation kind of thing. Okay. So broadly, these are the only two things that you will see. Most of the questions on simple equations are wordly. Okay. So instead of giving you a equation directly to solve, it will be way too simple. They'll give you a word problem. Okay, you have to read the word problem and then form an equation accordingly, and then use it for your solving part. Okay, am I audible now properly? Kunal, is it clear now? Okay. So for most of the linear equations, okay, you would find that the questions would be more of a word problem. And then in certain cases, they will also ask you to find out the number of solutions when it comes to simultaneous equations. Like you have the further three conditions. Okay, so in general, if you have a pair of simultaneous equation like ax plus by equals to c, and then there another one dx plus ey equals to f, both of them are distinct, of course, then you can have either a unique solution or you can have no solution, okay, or the thirdly, there could be infinite solution. Each one depends on the case, right? So these are the only three possible cases. So now just quickly identifying when they would have in unique solution or infinite solution. Basically, the idea can be seen from the perspective of graphical plotting of them. A linear equation is nothing but which represents a straight line. You can imagine these are the two straight lines, and the solutions are nothing but the point of intersection. Now, given an equation of a line, we can talk of the slope, you know generally as a coefficient minus time coefficient of you know x divided by coefficient of y. So in this case, the slopes would be minus of a by b, and for the second line it's minus d by e. Okay. Now, if you make the slopes equal, that will make the lines to be either parallel or overlapping, which is what results into the later two conditions. Okay. Now, in order to just simplify it further, we can rearrange it and write it as a by d and b by e, because that sees simply the coefficient of the x coefficients and the coefficient of the coefficients, right? So hence the conditions, that we will derive out. So in order to have a unique solution, there is no need to actually go and solve the equations and check whether you're getting a unique solution or no solution or infinite. You can simply say if the coefficients of the x a by d is not equal to the coefficients of y, which is b by e, then you're always going to get a unique solution, because this graphically would represent two lines which don't have will have different slopes. As they have different slopes, they are bound to intersect each other at some one point, and hence there'll always be a single point of intersection. When you say there are no solutions, it means they a by d equals to b by e. They have equal slopes and they are separated from each other. So that would represent a case when they are representing two parallel lines, right? Separated by a distance, different distances. So this should not be equal to the ratio of the constants, which is c by f, because constant in a way helps you to determine the distance of a line from the center, right? So if they are running parallel, okay, they would have same slopes and hence they will never intersect. Infinite is the case where they will actually intersect, not just intersect, but they will overlap. So if you see both lines are overlapping each other, then every point is common to them, and hence we will say there are infinite solution, for which they need to have not only equal slopes, which is like a by d equal to b by e, and also at the same distance, which is also equals to c by f. So if you see the ratio of the coefficients of x is equal to that of y and is also equal to the constants, that represents overlapping line and hence infinite solution. Their ratios of x and y's are equal but not the constant, which means they are representing two parallel lines at a separate distances and hence they will never intersect. So no slope will not be equal. Slopes are equal, so there will be no solution to that. And unique lines are a pair where they have different slopes and hence they're gonna intersect each other definitely at one point, right? So this is basically the condition that we'll have of them. Okay, now we go on to the questions on that basis. First, we're gonna discuss the questions based on linear equations. There could be some word problems, so you need to again understand how do you convert from that language to the maths equation, right? If it says x is 5 more than y. Okay, so that means x is 5 more than y, so we can write it as x equals to y plus 5. More than, less than, this much greater, that is all seen as a plus minus thing. But if it says x is 5 times, okay, y, then it would mean multiplication. Okay, so just read and infer whether that implies addition or subtraction or a multiplication in such questions. These are the only silly mistakes that one makes with that one. Okay, starting off with the first part, which is question based on simple linear equations. Okay, try. Guys, remember one thing always, you know, that these questions on linear equations are going to be very simple. So, since the topic itself is easy, there'll always be some trick involved in these questions. Because even in the harder section, if there's a question on linear equation, it means there would be some catch, something here, that would be tricky. You cannot have a very difficult question made on on this area, right? So always look out for that traps, these points where they want you to make mistake. Now here I see most of you have marked the answer as A because you would have assumed some values of x, y, and z and worked it out. So one easier set that you can take, easier set of numbers that you can take here is, let's say x is 6, then y would be 2 into 3, which would be 6, and z would be 3 into 2. So x is 6, y is 3, z is 2. So x minus z would be 6 minus 2, that is 4. And z minus I would be 2 minus 3, which is minus 1. And hence we see a is greater than b. But at the same time, you can also take the values of x as 0, y as 0, z as 0. All the three would be equal. Right? This would be 0, this would be 0. This would be equal. You can also take the values as negatives, minus 6, minus 3, minus 2. Right, the values could be negative. Then x minus z, would be minus 6 minus minus 2, which is minus 4. Right, 6 minus minus 2. Whereas z minus 5 would be minus 2 minus minus 3, which is plus 1. Even b could be greater. Right, so it could be anything. Right. So always keep your mind. You always keep looking for what is the trick that these guys have kept for me, and I need to avoid that. You just have to somehow step away from that. Yeah, exactly. They just send X, Y, Z. What are these numbers? So whenever nothing is said about these variables, they are always taking real values. So X, Y, Z would always be set of real numbers. Okay, that's how it's going to be. So think of everything: positive, negative, zeros, decimal, fractions, square roots, cube roots, everything possible. Try out everything. Somewhere or the other, you might get a contradiction. So for this one, it's actually option D, right? The answer option is D, not A, right? So two of you, Ludwig and I think who was there? You know, Akshat, both of you have marked D in that case, right? So there was the contradiction that you would have in this one. Okay, so be careful, right? From now on, especially in these data comparison questions. This is a simple word problem. Let's try this out. Easier. Okay, what about others? Let's quickly work this out as well. Okay, so let's try to look at it from two different angles. One is the way you're going to solve it, you used to do in school. We're showing each and every step because there we'll have marks for each and every step, right? So, three divisions, class A, B, and C. There's n students in A. So you start with a value for A, that is n, and the answer is in terms of n. This is what you call as VICs, you know, questions based on VICs, which is variables in choices. So the answer option doesn't contain numbers, they contain variable in it. Okay, so that's one category of questions on GRE. Okay, a good strategy, a simple strategy for these ones. I'll discuss it towards the end. When is the second one? One is like you solve it normally, get the values, and then mark. You know, solving the equations, framing the equations in this case, right? So then I need to look at any other condition which is linked to A. B, if I had three more, then it would be double of C. So that's a link between B and C. I don't need that first. Three fewer students in C than in A. Okay, now C linked to A. So three is fewer, so that's three less. So I minus three. Now B is related to C. What it says that if there were three more in B, okay, if I would add three more to B, then the number would be twice that of C. So B plus 3 would become 2 times of C. That means the B at present is 3 less than twice the C. Right? So therefore the value of B in this case I'll get is 2 times of n minus 3 minus 3. You know? That minus 3 because right now it will be 3 less. All I need to do now add this out. So n plus open the bracket 2n minus 6 minus 3 plus n minus 3. So solving this 2n, n, and n, that is total of 4n, and you have minus 6 minus 3 minus 3, which is minus 12. Right? So minus 4n minus 12, which we see as option C. Right? And that is the answer. Okay, so the one way is like actually going step by step and then solving it out. Now, generally, if you look at this, what does this n denote? This n in the end is some number, right? So one way of looking at these questions is just replacing these variables with some numbers. Okay, you can always, instead of using x, y, and z or a, b, c, or n, just assign some numbers. It becomes a lot easier to think in terms of numbers because just simply because our mind is hardwired like that. We think a lot more easier, especially if we have been from the from a technical background, right? You understand numbers, process numbers a lot more easier than the unknowns, than the variables. Variable is something that is unknown. No, it's a bit of a hang up condition for the mind when you're just talking of something that you don't know about, then actually for which you can assign a number, a value, and then work with it, right? So here, assign the numbers. Now, what value of n would be the simplest to start? I would say I'll take 10, because then the 3n and 4n would simply become 30 and 40. It becomes a lot easier to add and subtract from the multiples of 10. So let's say a is 10. Okay, c is 3 less, so c would be 7. B, if 3 more would have been double of C, which would be 14. So B in that case is 3 less than 14, that is 11. Right. So therefore, the total sum is 10, 11, 7, which is 28. Now I need to get 28 from the option. All I need to do is substitute n equals to 10 and see which option will be 28. This is 30 plus 12, 42. Of course not. This is 30 and 18, 48. No. This is 40 minus 12, 28. Yes. 40 minus 18, right, which is 22. No. And 40 minus 27, which is 30. So we see this is the answer here, right? So you can always replace these values, these unknowns, with the value, and then you can also simplify. That's one easier way that you can work on. Okay, use numbers instead of variables. Okay, this one is slightly jumbled, so I'll write down the actual terms. Okay, that is 2a plus b over a, and then this is ab. So this is the same here. Samyuk, is this the attendance thing? Is the link to the attendance? Okay, so let's try this one. See what is the answer. Good that you did. I was just about to, ask you the same thing. Okay, you can run the attendance. Also, Samyak, if maybe after this class, if you can, just call me and we can discuss it out, because I see the attendance has been dropping. You know, it's quite less today. As there since last two classes. I'm observing that. So let's try to work it out. Let's try to work out a solution here. Hmm? So maybe after the class, just give me a ring, and then if there's any issue, we can discuss it out, and I can take it forward to the company and the college. Thank you so much. Surely it is A. D. There comes D, but with a question mark. See, what you see here is that AB is minus 1 by 2. It's a ratio which is negative. So there are two possibilities. You can have either A by B as minus 1 by 2, or it could also be 1 upon minus 2. So one thing which is sure, that one of the A or the B is negative, but not both. So as one of these to be negative, so AB to definitely negative yoga, right? So AB has to be a negative value. Clear? Now I'll just try to simplify this. Okay, I can split this as 2A over A plus B by A, which is 1, because sorry, that would be 2 2a by a, so you can see the a will get cancelled out. So that is 2, and then it's b by a. A by b is minus 1 by 2. So b over a would be actually minus 2 by 1, which would be a minus 2. So plus a minus 2. That will give you 0. So whatever value of a and b that you take, it's always going to cancel out, right? Irrespective of the value. So hence, this is 0. This is some negative value. So a would always be bigger than that. In fact, you could have also cross multiplied. You could have seen that 2a actually is minus b. So you can see it from here. You cross multiply, so 2a would be equal to minus b, and then you can substitute minus b plus b, which would always give you this. Right. So a is the answer. Let's check. I'll go ahead with a as well. Right? Yes, a is the answer. Perfect. It shows there at the base. Right? A is correct. Let's go to the next one. Okay. A word problem. Check. Yes, correct. Right. So we don't know what is the total number, right? So what is given here from the question that 37 books are priced less than 20. So you can say the number of books which are, priced, let P be the price we are talking of, less than $20, right? That is 37. 40 books are priced not more than 20. So price which is not more than 20, which is uh, less than or equal to 20, that is 40. Now from this we can conclude that the number of books which are priced exactly at $20, that are 3, right? So we know that if there were n books, okay, in the shop, then the remaining n minus 40 they all have a price which is greater than $20. So because we have already classified, there are only 40 of these which are not greater than 20. Okay, not more than 20 means it could be 20 or equal to 20, okay, but not more than that. So hence we can say that the number of things which are at 20 equals 3. Now number of books in the shop that are priced above 20, that we don't know, that would be n minus 40. 77, we have no way to compare, right? So therefore D. I don't know the total number, hence I cannot decisively say whether this is more than 77 or less than 77 or maybe equal to 77. Anything is possible. We're not very sure of that, right? So therefore option D is good. One minute, let me see. Shantanu, what's... No, 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 no. No, that is because these would lead to some assumptions, right? And these questions does not allows you to make any kind of assumption to solve. In fact, they want you to make wrong assumptions and make a mistake there. So you have to take it just the way it is given in the question, not a point less, not a point more, nothing at all. Okay, it should be just on the face value of the question. Otherwise, you will just fall in their trap. That is the thing. Okay, there's another word problem, but a lot simpler. So work it out. Check. Okay. These are the multiple answers. One, so all of these which were. So the first thing to check is that the father is 3 times son. So all the numbers actually 36, 45, 3, 62, 3 times 24 into 372 and 13, 3, 39. None of them gets eliminated because of that. Also, now we need to see that the sum of the father plus son, which actually is 4 times son, right? Because father is 3 times, should be okay greater than 50, right? So can be any value from 51 because it has to be greater than 50, so cannot be 50, but less than 85, so it should be 84. So all these values are acceptable starting from 51 up to 84. Okay, generally at that strictly greater than thing, I actually skip that part and write it as the greater than equal to with the next number, greater than 50. So I'll not say strictly greater than 50, because sometimes in a hurry, if you see 50, you might end up accepting 50. Okay, so instead of saying greater than 50, start from 51, and less than 85. So instead, less than 85, because if I write that this, the sum, and this is 85, then in a hurry, sometimes you just don't, you overlook that it's not equal, it should be strictly greater than, and you may in a hurry accept either a 50 or an 85 there. So convert this to this. It's simpler. Huh. Right. ले देना. So 12 3 is 36. So it's like 4 times the sun. So 12 fours are 48, reject. 15 fours are 60, yeah, that is accepted. 20 fours are 80, you know, that is also accepted. 24 7 96, reject. 13 fours are 52, lying in the region, yes, accept. So therefore it should be B, C, and so B, C, E should be accepted. उसको वो नीचे रख दो, मैं बाद में ले लूँगा. Okay, that should be the answer, right? B, C, and E. Yeah, not D, because D would be 96, which is outside, right? Right. So just check the options. In fact, in such questions, remember, you would have nearly around 8 to 10 answer choices, because it is not a very difficult one. You just have to work with the options, so they'll make you spend a lot of time on the options. You can have around 10 options or 11 or 12. It can go as many as that. And remember, if you make mistake with any one of it, you're gonna get that wrong. Okay, so such questions will have a lot of options. You need to check carefully for each one of them, because one option missed or one extra mark will, get you to everything wrong. You lose everything. So that's where they make it a more trickier. Okay, now let's go on to the next question. It's a comparison question again. A good question. Let's see. Okay. Again, let's see. Good difference. So a lot of B's and the D's as well. Okay. Now, this is given to be equal. So we need to understand the equality here. What is given is that 10 times of m square is actually equal to 100 of m square. Right? Now, what value of m would satisfy. Now, if you try to cancel m square because it's either 0 or positive, if it is non-zero, you cancel and you're going to get a contradiction that 10 equals to 100, which is definitely not true. So the only value that will make it, you know, satisfy m equals to 0. Because if m is 0, m square is 0, and that's the only way you will have 10 m square, which is 0, equals to 100 of m square, which is also 0. So the only value that satisfies this is m equals to 0. In fact, you can, if you need to do a bit of algebra, you can take the term that side, which will give you 90 of m square equals to 0. So of course, 90 into m square equals to 0, that means your m square has to be 0, which will lead to m equals to 0, right? So here m is 0, b is 1, so therefore answer has to be b. So b is the right answer. Okay, so a good tricky question here again. And if they say, you know, if the question was 10 m square is not equal to 100 m, or 10 m the whole square, if it is not equal, right? Let's say the question is like this. Okay, let me change, in fact, write it like this, the way it is written in the question, 10 of m square. Then what would be the answer? So it was given to be equal. Let's take a case, when we say it is not equal. 10m square is not equal to 10m the whole square. Let's say if it is the condition. Right. Hmm. So they should not be equal. So you can have any value of m. Remember, m can be positive or negative. Right. So first, then it would be surely d. Perfect. Then it can have any value of m. M could be negative, positive, or anything. Right. So then it would be surely d in that case. Okay. Chalo, let's go to the next one. Let's see this one. Okay. Let's try this. Okay. Let's see here. Okay. E. Right. So it's given that x into y equals to 64. Now, what could be the possible factorization I can have of 64? 1 into 64, and then 2 into 32, and we'll have 4 into 16. Okay, and then 8 into 8. These are the different factorizations I can have. Okay. Now, since it is given that x and y are integers, So besides this, you can actually also have a plus minus sign. So it's not just only, you know, plus. It's a plus minus thing because you can also have negative values from it. Right. Now, since we need to find the minimum possible value, so the minimum would be when it's minus 1 into minus 64. That will add to minus 65. In fact, the maximum would happen when it is 1 into 64, which will add to 65. Right? So you can have the sum as, you know, minus ranging from minus 65 to plus 65. That can work out as it is given out to be integer values. Yeah, you can change, in fact, once you can go back and change your answer in case. So you can review it. Okay, but once you have submitted the section, then it is gone. Then you cannot go back to the original because based on your accuracy in that section, the level of difficulty of the next section is decided. No? So in fact, you can just skip some question, don't mark them, keep it for the review, and then go. You can go back and answer them later on. So there's this flexibility, that you have on GRE, which is not there on GMAT, but it's there on GRE for sure. Right. So in this case, if it was given to be, let's modify this again. Say if it was a positive integers, then what will be your answer? Xy is equals to 64 and x and y are positive integers. Then what is the minimum possible value? Right. Then you need to take only the positive cases, which is 8 into 8, 8 into 8, which will give you sum of 16. So the rule is whenever the product is constant, okay, the sum is maximized when both the numbers are as far away from each other, and the sum is minimized when both the numbers are as close they are to each other. Okay, so to maximize, that's only for the positive values, right? In case of you're considering only positive. To minimize, get them as close as possible. You have to maximize, take them as away as possible, which is 1 into the number, which would be the maximum separation that you can have on that one. Right. Now, if the same question also I have to make it a little harder, right? The same question, then how would I reframe that? Same condition, then how many possible, you know, values of x plus y? Then how many possible values x plus y can take? Xy equals to 64 and x and y are integers. Then how many possible values x plus y can take? Now what will be your answer? See, now this becomes a little tricky. Instead of checking for the maximization or the minimization. So here then I would need to actually go and factorize it, right? The way we did. So it will be plus minus 1 into plus minus 64, you know. Then it can be plus minus 2 into plus minus 32, what we have seen, plus minus 4 to plus minus 16, and then last case of plus minus 8 into plus minus 8. Right, so this would give you two possibilities, 1 and 64, minus 1 minus 64. So every positive sum, negative sum, 2 and 32, minus 2 and minus 32. Right, so therefore, in that case, this would generate total of 8 different possible values. Okay, do not take the cross one, like 1 and minus 64. This will not be possible, because the product in that case is given out to be 64. Right, it has to be positive. If it was xy as minus 64, yeah, if the product was given as minus 64, then still 8. Correct? Yes. Because now then I have to take opposite signs, right? One should be positive and the other should be negative. So now minus 1, 64, and 1 comma minus 64. These cases will be considered. Either one of them should be negative. Yeah, perfect. So these could be the other different, combinations, different type of questions that can be reframed on the same logic. Okay, so that's the simple approach that I need to take for this one. Okay, now uh, take it. We go to the next one. Yeah, minus 65, which was the answer. Okay. Now the comparison again. This is slightly misaligned. So your A and B. A is x plus 1 by x the whole square. B is x square plus 1 upon x square. Okay, these are the quantities that you need to check. Please take. Okay, let's see for this one. Is it D? Check. Ryan, just check again. Okay, most of it coming out to be A. Right. So if you simplify this, yeah, that's A itself. It is x square plus 1 upon x square, which is the same term as B, and a 2 because x into 1 by x cancels out. So this is definitely positive. This term is a positive term, right? Because x square is always going to be positive, and it's given and x and y are both non-zero, so you cannot have a zero here in that case. So this is going to be a positive term, and to positive, whenever you are adding a positive number, this will always going to be greater. So therefore, answer is A. Yes, A is correct. All right, next one on the same lines. Check this one carefully. Right. Now is the answer for this one. B greater. Will it always be? See, that's a catch. Will B would be greater now because you don't know. So when you simplify, this is x square plus y square, which is B. This is the B part, and it's a plus 2xy. Okay, now you don't know that this product xy is a positive or a negative term, right? So this could be a positive term. This could also be a negative. If it is positive, it's getting added to B, and hence that would make, A to be greater. But if it is a negative, then it is getting subtracted from the value equal to B, and hence would become lesser, right? So you can have either A greater than B or less than B, depending whether it is a positive or a negative case, right? So therefore, the answer should be D. We cannot say for sure because we don't know what are the signs of the product XY. No, both X and Y. So can't be said. So that's why, it will totally turn. In that case, X and Y was getting cancelled. It was purely 2, which would increase. But in this case, it could be positive or negative. We don't know for sure. And hence, that's why this would, not be give me a definite answer. So hence D. Now, moving on to the quadratic equations. Okay, let's check this one. That's E, right? So in general, whenever we see ax squared plus bx plus c equals to 0, we know the roots by default are minus b plus minus under root of b square minus 4ac the whole divided by 2 times b. Now, so this discriminant delta, which is inside this, that's your delta. That is b square minus 4ac. Now, whenever a is negative or c is negative, any one of them, this is always going to be greater than or 0, because the negative of a or a negative of c will make the sign as plus. So there will be no question of the roots to be real. They will always going to be real roots. The only problem would come when a and c they both are positive and b is small, a very small value, so that this can turn out to be less than 0, which can lead to delta to be less than 0 and hence no real root. You never say that the roots are complex on GRE. They will always refer that no real solution, right? So here you see at the first look itself that both a and c are positive. So minus 4ac would, the 4ac is going to get subtracted. Okay, and the value of b is just 1, so b square is also going to be 1, so definitely delta would be negative. As delta is negative, they would have no real roots, and hence the answer option E is correct. Right. So E is the right one. Perfect. Okay. Now here, before we go to the next question, actually, let's just discuss out a small thing in here. Now, as you see that a quadratic, ax square, uh, like ax square plus bx plus c equals to 0, has two roots. Call this as alpha minus b plus root delta over 2a, and the other is beta, which is minus b minus root delta over 2a. So when you find their sum, which is minus b by a, minus b by 2a minus b by 2a, and the product, as we know, using the square completion, x plus y, x minus y, you know, comes out to be c by a. So here, if you divide throughout by a, you're going to get x squared plus b by a times x plus c by a equals to 0. And we know a definitely is a non-zero, because if a is 0, then you won't have any quadratic in the first place. So a has to be non-zero, so we can divide safely by a. And we can just rewrite this a little bit, which will give me minus of minus b by a times x plus c by a 0, which takes the form of x square minus the sum of the roots alpha plus beta times x plus alpha beta equals to 0. Right. So x square minus sum of the roots times x plus the product equals to 0. Now this is a very important relationship, okay, by which you can actually go back and construct the quadratic itself. So given the roots, you can very easily identify what is the quadratic in the first place. Okay, makes the whole solving a lot easier than actually compared to finding the roots and working out. So you can eliminate the options a lot faster and quicker with this one. Now, if this used to be one important part. Usually, when we are solving questions for the on the quadratic, you know during our JE preparation and all that. So there used to be this part which will have a lot of questions based on the sum and the product of the roots. Now, one advantage here that you can see, you can identify the sign of the roots, by just by merely looking at the sign in the equation. Say, for example, that is a quadratic equation, and these are the roots alpha and beta. So if the equation is of the type x square minus 5x plus 6 equals to 0, remember this is the sum, this is the product. So what you see, the product is positive. That happens only when both the roots are either positive or both are negative. And look at the sum is positive also. So because it is x square, remember the time, it's x square minus sum plus product. So by default, it's a minus here and a plus here. So this minus sign remains as it is, which means the sum is positive. It has not changed it. So sum be positive and product be positive, and that means both the roots should be positive. So whenever you see the quadratic is minus, what I'm saying is, whenever you see the quadratic has the sign of a minus plus, both the roots is always going to give you a positive answer. So minus plus is positive roots. Similarly, if you have x square plus 5x plus 6, product positive, but the sum ka sign has changed from minus to plus, which means both the roots are negative. So whenever the quadratic is with a plus plus, that means both roots have to be negative. You can quickly eliminate all the options from there. If it is x square, plus 5x minus 6 equals to 0. Product is negative, that means one root is positive, the other is negative. The overall sum of the two is also negative, because that minus is changed to plus, which means the negative one has a higher magnitude. So the roots would be something like, say, minus 6 comma 3, where the sum is minus 3 and the product is minus 18 times. And if it is x square minus 5x minus 6 equals to 0, again a positive and a negative, but this time the magnitude of positive is greater. So just by looking at the sign, it's a minus plus, both positive roots. It's a plus plus, both the roots are negative. It's a plus minus, okay, negative, greater than magnitude than positive. And if it's a minus minus, positive greater in magnitude than the negative. You don't even need to solve it. You just identify it from the options and then work on it. Also, okay, certain conditions here, if your b is 0, that means there is no x term. B is 0, no x term, right? So then your b by a is also 0, which means minus b by a would also be 0, means alpha plus beta will also be 0. That will mean alpha equals to minus beta, right? The roots are equal in magnitude but opposite in sign. Something like say x squared minus 36 equals to 0. There's no x term. The roots as you see is plus minus 6. Equal in value, that is 6, but opposite in sign. Also, another case, okay, just like this, if you see the coefficient of x squared and the constant, they are same. It's like say 5x squared minus 12x plus 5 equals to 0. These two values are always equal, right? So that's the case when c equals a. So c by a equals 1, which means c by a is the product, alpha beta equals 1. That means alpha is 1 over beta. The roots are reciprocals of each other. Okay, that's one more condition that you can keep in mind. Right. No, b0 means roots are equal in magnitude, opposite in sign, and a and c equal means roots are reciprocal of each other. Right. Okay. Now we can go to the questions and try. Check this one. Okay. So b, right? Okay. Now you can see it in two different ways. You can say that alpha plus beta as comparing with x square minus sum plus product. Alpha plus beta is a, you know, and the product alpha beta is 6. Sorry, in this case m and n is given, right? So I'll use m and n instead. Okay, so this is m plus n, the sum, and this is mn. Now for the new quadratic, you know, the new equation, the roots are 2m and 2n. So their sum 2m plus 2n will be 2 times of m plus n, which is 2a, and the product 2m into 2n would be 4mn, which is 24. So therefore the equation would be x squared minus 2a x plus 24 equals to 0, which is option A. Right. Yes, you get that by solving. So you can just solve and get, you guide the original root, take the new root, whatever it changes to, and then write down the sum of the roots and the product of the roots, and work it out upon. Gets you the answer. Or another way that you could have seen is just assign some value of x, right? So you can say x squared minus 5x plus 6 equals to 0, which will give you the roots as 2 and 3. The new roots would be 4 and 6. So the new equation would be 10x plus 24. Yeah. So this becomes 2 times a. A was 5, this is 10 minus 10, so double. So hence B, which fits. Okay, this would have been a lot simpler if you would have wrote down. Okay, what would be the equation if the new roots were to be m by 2 and n by 2? What should be the corresponding equation? That's right. It will not fit into one of the options, of course. Instead of instead, if the roots were double, instead of 2m and 2n, if they were halved, I had one root as m by 2, the other as m by 2, then what would we get? Right? So m by 2 plus n by 2 would be m plus n by 2. M plus n is a, so a by 2. And n by 2 into n by 2 would have been mn by 4. Would have been 6 by 4. Used to 3 mn is 6, right? So the corresponding equation that we'll get be x square minus a by 2 x plus 3 by 2 equals to 0. Right? So multiply that by 2 because we don't keep it as a fraction. So 2x squared minus ax plus 3 equals to, yeah. So after cancellation. So this is still easier. One tricky part in this one is, suppose if you have to form a new equation that will have the roots as 1 by m and 1 by n. The roots needs to be reciprocal. Then what would be the corresponding equation? Here the roots become reciprocal of the original. So therefore, sum would be 1 by m plus 1 by n, which is m plus n upon mn. M plus n is a, mn is 6. And product would be 1 by m into 1 by n, which would be 1 by mn, which is 1 by 6. Right. So therefore, the corresponding equation would be x squared minus a by 6x plus 1 by 6 equals to 0, which will give it as 6 of x squared minus ax plus 1 equals to 0. Right? So that will be the corresponding equations. Yeah. Right. So other type of combinations that had been asked in the past on this type. Okay, it's just a simple manipulation of the sum and the product from the original, and then you can substitute and form the other equations as well. Okay, now let's go on to the next one. Yeah, B is the answer for this one. Okay, check this one. Okay, so this can be again further simplified by assuming y as x squared. So therefore, y squared would be x raised to 4, and hence you can rephrase this as y squared minus 5y plus 4 equals to 0, reducing it to a quadratic. Now, which we know this is 4 into 1, but minus 5, so minus 1 into minus 1. So the roots would be plus 1 or plus 4. Right. But then we are not looking at the value of y, we are looking at for x. So therefore, x squared is 1 or x squared equals to 4, which means x equals to plus minus 1 or x equals to plus minus 4. Right. So we'll have these four values. Right? Sorry, my bad. My bad. It's 2. Okay, so it would be 2. Okay, sorry. That's just a slip. It should be a 2 here. Right, so it's going to be a minus 2, minus 1, plus 1, plus 2. B, C, E, F. Yeah, that's correct. B, C, E, F. That's the answer. Yeah, B, C, E, F. Okay, go to the next one. Try this. It's good. Tricky. Okay. B. Now we have there is this B, a lot of B's. Okay, and that's one A. What would be a good way to work on this? Any shortcut, or actually you worked out? So if the question was what is the minimum value, so can you tell me? Acha, okay, one thing is by assumption. Okay. Now, if you have to find out, the value -4, right? Yeah, exactly. It goes below x-axis, right? Right. So what we see here is, okay, for any quadratic equation, the number of roots that you can have. A quadratic can have either number of roots as 2. If there are two roots, that means the quadratic is actually cutting the x-axis at 2 points. So this portion is negative, it's positive here, it's positive here, right? So the minimum would be a negative value. Second is when you have these other two roots, when there's only one root. Okay, that means it just touches the x-axis and it just kisses the x-axis and it bounces back. So you're gonna have only one real. And then there is no negative y happening in that case. Y minimum would be 0. And the third case, when there are no real roots, that means the quadratic just stays above totally. Right? In this case, again, there is no negative value. The minimum is positive. So in this case, you know, as it is opening upwards, we will always talk of the minimum here. So minimum is negative when you have two roots. Minimum is 0 when there is only one root, and minimum is positive when there would be two roots. Okay, now the condition for these two roots, that delta should be greater than 0. Now if you look at the discriminant, delta is greater than 0. In this case is delta equal to 0. In this case is delta less than 0. So one way is quickly to check the value of delta, which is discriminant b square minus 4ac, which can guarantee it. Right. So that is the first method, to check for the minimum. So here b square minus 4ac would be 8 square minus 4 into 1 into 15, and that's 64 minus 60 greater than 0. So hence this would be a negative value, whatever it is, this is 0. So b would be greater, right? So that's one thing. Second way is actually finding out the values, you know, what is the minimum value and at which point it happens, correct? So we can use another method, algebraic method, which is called as method of square completion. So given that y equals to x square plus 8x plus 15. So I'll try to complete a square by adjusting 8x, plus a 16 here would make it complete square, because comparing it with, generally x plus k the whole square, let's say, if it is x plus k the whole square, the expansion is x square plus 2kx plus a k square, right? So the square that needs to be adjusted is the term here, 2x. So 2x is 8, 2k is 8, so k is 4, 4 square is 16. So I write this down as this, okay, minus 1. And this one then gives me a complete square, x plus 4 the whole square. Let me just write this clearly. This is x plus 4. Right? So this is x plus 4 the whole square minus 1. Now observe, squares are always greater than or equal to 0, right? So when you have to have a minimum, that means, see, it's the y value will always be square minus 1. As x increases, the y also increases because the squares are increasing. So minimum will happen when this term is 0. So minimum of y would happen when it is 0 minus 1, which is minus 1. Okay, happens at x equals to what value of x will make this 0? Minus 4. So you get the y minimum as minus 1 happening at x equals to minus 4. So this form, the square completion form, would give you the minimum, which is this value, and the point where this happens, which is the value of x that will make this as 0. Right? So hence, this would get you both the points quickly. Although it's a little lengthier method because you're treating it algebraically. Okay, so it takes time, but another quicker way of finding x that will always yield to y minimum will be minus b upon 2a. So whenever x is minus b upon 2a, your y will always be minimized. Okay. I'm taking all the cases when it's opening upwards. For the cases when it is opening downwards, that means your parabola will have a shape like this. This point will always be a point of maximum, which happens for negative value of a. When the coefficient of x square is negative, right? It's just with the reverse. So this is the point at which this will give you the y minimum. You just take this value of x, substitute the equation, you get the minimum. Like here in this case, if I have to find what value will give me a minimum, minus b. So minus of b is 8 upon 2 of a. A is 1, which is minus 4. So at x equal to minus 4, y would be minimum. So what will be this minimum value of y? Substitute minus 4 square plus 8 into minus 4 plus 15. Right? This is minus 16. That is plus 16. 4 8s are 32 plus 15 minus 32. So this is 31 minus 32, which is minus 1. That will give you. Okay, so you can quickly find out by this. So the condition is x equals to minus b upon 2, which leads to y minimum or a maximum. Okay, depending on what is your the condition given, whether your x there is, you know, positive or negative. X squared term is positive or a negative, and accordingly, you need to figure out whether this has to go, whether it's a maxima or a minima. Now that term actually, if you see, can be easily figured out. That's what we used to do even in the derivative method. So you can say that for a general quadratic equation, y equals to ax square plus bx plus c. If you take the first derivative, that's going to give you 2ax plus b, which we equate to 0. And that leads x to minus b upon 2a. So that is a point at which the maxima or the minima happens. And that is what we need to use. Yeah, that is what exactly. That is how you got the value of this x as. Yeah, you can very much use the differentiation. Right? Perfect. So using the differentiation, you get this value as x is minus b by 2a. So just remember, you know, that the minimum will happen at x equal to minus b by 2a, and find the value of x, substitute, you get the minimum value also directly. Right? So all these questions of these types can be worked out through this. As they are simple, it's just easy, simple solving. Right? Okay. Oh, so that brings into the end of the first part. Okay, which is your linear and quadratic inequality, quadratic equations. The inequality and absolute value is what we're gonna, continue from the next session. So that is your algebra 2. Unfortunately, last Monday the class didn't happen because of net issue at my place. So today was supposed to be the algebra 2, but we ended up covering the algebra 1 in that case. Okay, so anyway, I would get it rescheduled. I'll tell them to schedule the algebra 2 for the next week, so that we are, as per the schedule itself, is going on the schedule part. Okay. Now, any questions, any doubt that you have till now, or any other help that you guys need, you can just let me know. As far as that material is concerned, I think we just spoke at the start. Maybe some of you were not there. That you guys need some practice material, you know, that is related to GRE. So I'm gonna make one drive folder, okay, for all you students, and then I can share it out with one of you, and you can post that in your WhatsApp group, or in here where you can just download all the relevant material from there. So maybe Samyuk or even I've been in touch with, okay, both of you. I can I can forward you once that link is done. Okay. Shantanu is there, Samyuk is there. They are in touch with me. Okay, that is an important question. When should you register for the test? Now tell me, which year you are in. Are you the third year, fourth year, second year? Because the timeline would vary. Third year guys, right? Okay. When is your exam schedule? When are you having your odd sem exams? Third or the fourth year? November end, right? Yeah, 20. I think Bombay. No, yours is VJTI is an deemed university. No, now they are not anyway under Mumbai University. No, yeah, that's autonomous, right? Correct. So 23 30th should give in November. I think you should target sometime around Jan end. Okay. Yeah. So by November end, if you're done with your everything, okay, Jan, Feb, yeah. So around Feb or March would be that. By Jan end, I think we will be completing with our course because there would be, I think, a break that would come. Acha, do you guys need a break for your college studies or something? Is there anything that got worked out? Which discuss हुआ है? It's still time, I think. You know. Huh. Yes, Samyuk. Yeah, Shantanu, you can let us know in that way. Okay. So the classes may go on till end of Jan, and then we'll have some workshop sessions for you, like tough questions, 320, 325 plus types, and mock test discussion and all that. So I think, by around Feb end to the mid of March would be an ideal time, because then your next exams may be, scheduled for somewhere in April or April end, right? Huh, correct. So that would be there. So I think max by mid of March should be done. March to that one. That is the target we should keep for all the third year people. Right? I'm telling this for all the third year people. People who are in the fourth year, okay, they'll have to apply for the cycle. So their application would start by December. So they need to take it by the December end. I don't think there is any fourth year guy here. Anyone from the fourth year? I think majority of you are the third year students only, right? So no fourth year. Okay, that's fine. Okay. So in fact, I've shared my number with you also. So if you want, you can call me and you can discuss with me. Okay. So please feel free, you know, to call me if you need any if you need to discuss out anything. You can feel free to get in touch and discuss it out. I'm again sharing my number. Okay. You can very much get in touch anytime. For now. 9820996383. Right. So the next part of it, which is inequalities and absolute values, we will continue in the next session. This is going to be a little trickier one because you know uh, your the second part, the inequalities and the absolute values, is a challenging part. Okay, that's usually slightly tougher as compared to the first part, which was this thing, linear and quadratic. That is easy. Okay, so next case gonna be a little more challenging. We'll work it out there. Okay. So, all right, Samyak, if you can get in touch, there was just think that we can discuss it out about the change in timings if that's needed, and how do we go about that? Okay, so take care, guys. All the very best. Stay safe. I'll see you again next week, Monday at 5. We'll continue with the second class of algebra. Okay. All the best, guys. Study well. Take care of yourself. Stay safe. Bye bye.